All right, welcome everybody. Tonight we're going to be talking about integrating AI into our product at Briefly, some of the successes and a lot of the failures. For those of you who don't know me, my name is Ben Pomerenke. I've been a software developer for almost 20 years, getting close. And I'd like to think the time that I've been a software developer, it's been really cool in technology. You know, before I even started my journey into this career, the dot-com bubble was growing and eventually burst. But a lot of really cool web technologies came out of that. As I went through college and into my early career, smartphones came out. You could do a lot of cool stuff with the power of a smartphone in your pocket. So things like social media, apps, a bunch of different cool stuff. As I got further in my career, transitioned to being more of a web developer, so I got to work with a lot of really cool web frameworks, and found my way kind of into cloud computing, so doing a lot of orchestration of deployed environments. Really cool stuff. Still mind-blowing how much you can do with a few lines of scripting. But it's all kind of come to a head recently, somewhat recently, with the technologies around AI. So when you say AI, you're probably thinking large language models like ChatGPT. It turns out a lot of the technology that goes on inside of AI has been around for a while. Just 10 years ago, I was working on some natural language processing, doing some stuff that I thought was really cutting edge at the time. It turns out a large language model makes it seem pretty silly. So anyways, tonight I'm going to be talking about the things we've done to approach integrating AI into our product. So before I get into it, I just want to tell you a little bit about our product. This is a little bit of a plug. So we build a product called Briefly. So at its core, Briefly is taking data off of documents, either paper or digital, and extracting that data with a high level of accuracy, getting it into systems of record, things like ERPs, WMSs, TMSs. Our target audience for this tool is warehousing and logistics. You know, when I first heard the idea of this product, I was like, this is kind of silly. It's 2020, you know, I think it was 2022. Like, don't the computers know how to talk to each other? And it turns out they do. Warehousing logistics has a standard format to transact data between different providers, but it's long and it's tedious to integrate. It's very customizable. It's called EDI, and it can take anywhere from 6 to 8 weeks just to integrate two different vendors together. So our initial target market is actually what's called third-party logistics. These are warehouses that rent out parts and pieces of their warehouse to different people. And so they can have anywhere from 40 to 80 different vendors. And so integrating with every single one of them is sometimes unmanageable. So our tool gives them a lot of that benefit of having that seamless data connection, but not requiring that they spend that 6 to 8 weeks to integrate. Because of the nature of our tool, anytime we attack problems with technology, we have to take into consideration a few pretty fundamental things. So first and foremost, our solution has to be consistent. If they're extracting data from these documents and they're getting different answers every time, it's kind of a problem. Warehousing and logistics actually has this concept of what's called chargebacks. If they get the data wrong, they actually get fined by whoever they're moving the goods for. And that can actually add up really quickly. So we want it to be consistent and accurate. Also, our customers, you know, they're using this because they believe it is consistent and accurate. If it starts throwing in random data or hallucinating, they're going to lose trust in it and go back to the way they were doing it before, which is just by hand. Our solution also needs to be flexible. So I mentioned the third-party warehouse. You know, that there's all kinds of variety of documents that we need to be able to handle. They are all very similar classes of documents, things like bill of ladings, packing lists, receipts, invoices, things like that, but they're all formatted differently. They're all generated by some computer system, and there's hundreds of them, and they all have a slightly different format. So we can't do data extraction like the way you can do with OCR, where you will, you know, look for a certain part on the page and pull the data from there. We have to be flexible enough to be able to handle any document format. And then last, we need it to be quick. We need to be able to beat the time they spend manually entering this data with our solution. So all of our technologies need to come back, you know, somewhere between 15 and 30 seconds. That's about what people will handle And there's ways to make it, to work the system so that it can be a little slower, but most of our solutions need to be pretty quick. Before I get into the specifics of our situation, I did want to call out one concept that kind of helps me put into perspective what it's like to be a software engineer, and that's the whole idea of failing forward. So when you are building software, as a developer, you're pretty much failing all the time, whether you want to believe it or not. You try a syntax, doesn't work, you change it, you adjust. That's a failure in a very small way. You build a new feature, you put it out in market, customers don't use it the way you think they did, there's a failure there. So it's just part of the job. So if you are an aspiring software developer and you don't like to fail, you probably should maybe consider rethinking your choice here. But the cool thing is the faster you can fail, the less you will waste. So everything we do in our product development is all about getting a fast feedback loop, seeing something work or not work, and then being able to adjust quickly. And then the last thing is every failure has a silver lining. If you're failing at writing the correct syntax for maybe a language, you're learning what the right syntax is along the way, and you actually you fail less and less. Same thing with product features. If you put a product feature out there and people use it in a way you didn't expect, or maybe it doesn't work the way you wanted it to, there's a lot to learn from that. And so we take stabs at features and different ideas and try to look for the silver lining every time. Before I move on, I just want to call out, I don't know if you guys can read this from over there, but I'm a father of three. I have 3 daughters, great kids. The oldest is 11. And we have a book on our shelf called Rosie Revere Engineer. And every time I'm doing something stupid or I make a mistake, I always think back to this book, because in this book, there's a little 7-year-old that is an inventor, and her invention fails miserably. And she's distraught, she wants to give up, and her aunt reminds her that you're always going to fail, but the only true failure as an engineer is if you give up. So as we're working through these problems, the key is to not give up, to push through it. That's where the real wins come from. All right, so let's get into the details. So I'm starting off easy. These are some of our early successes. So when we started our company 2 years ago, I was actually very skeptical that we could make this work because I didn't think we could handle the variety of documents, the different levels of data we wanted to get. And so we did some proof of concepts. And what we really found was there's this technology that's called, I like to refer to it as semantic extraction. So instead of trying to find a location on the page where the data lives, you can actually index the data based on its correlation to other things on the document. Okay? Amazon has a tool out there. It's called Amazon TextTract, and it gives you the ability to ask questions about documents. You've probably used a similar tool with ChatGPT. I think they let you do the same thing. The technology is probably slightly different, probably a lot of overlap though. And so early on, we were seeing a lot of success with this. It was intuitive. You could just ask a question. It would give you a pretty good answer. The text on the page didn't have to match what you were asking for. It just had to be semantically similar. And we could even do some prompt engineering, some very lightweight prompt engineering. And so this is where we started. We saw a lot of success here. In fact, we saw so much success, we thought we were ready to go live. The failure that we ran into eventually was there is only certain classes of data you could get this way. So you can ask questions like, what is the tracking number, and get a pretty good answer. You could even refine that by saying, like, what's the tracking number that starts with an S? However, it doesn't do a really good job at getting addresses, believe it or not. And if it did get addresses, it wouldn't give you a structured address like we wanted to have. It also struggled with getting line item detail. So tabular data on the document, it could give us one answer really well, but it couldn't give us 5 answers for the same question. And so we ran into this struggle, I'd say about 6 months into the company existing. And that's where comes our next technology that we started to implement. And this is custom extraction. So we could get a lot with the AI tools that were the semantic extraction. We didn't really do any of the engineering there. But for the line item detail, we actually had to write some custom algorithms. So the first and the most massively terrible part of this algorithm actually came from our first customer. I was out in Salt Lake City. We had some of the nuts and bolts there, but they had all these special cases we didn't account for. So we kicked off the customer in the morning. By the afternoon, I knew what all the issues were, and that night I went to the coding and created some pretty ridiculous and janky algorithms to get this data out. But it worked, and the customer was excited about it. In fact, they saw value immediately from that, couple hours of coding and handling those special cases. So we've evolved this algorithm over time. We started realizing that if we just know what the customer really wants, we can customize the algorithm and do some really cool things. And so it's evolved over time. We've actually seen some pretty interesting patterns evolve as we've been doing it. And so it actually has become a big part of our system. It's not AI. It's just route algorithmic extraction of data from semi-structured data. The only negative side of this is it only works with tabular data. So some of these forms actually have the data that you need somewhere else on the document or in a really weird format. Most of these forms are optimized for the warehouseman to be able to see one data point and not have to repeat it 5 times, so it's not really tabular. It's kind of like some of the information's up here, some of the information's over here. And so this actually falls over pretty easily when it comes to that data. Excuse me. So we're working through this custom algorithm, and at this time it was very, very immature. It was very janky. It wasn't as clean as it is now, although I think I'm the only one that thinks it's clean because I know how janky it used to be. Our team doesn't want to touch it if they can help it. But we thought, hey, why don't we try to throw an LLM at this, right? And LLMs, so this is probably 6 months after ChatGPT kind of really got popular. But it's also like 3 months after the Meta model, so Llama, was publicly released. I think it was first leaked, but then it was publicly released. So there's this whole community of tools that were built around this technology. And so we attempted to host our own large language model. We ran into a few problems. So first and foremost, it was very expensive. It actually, I think at the time, was about 50% of our AWS costs. And then the most important thing was it was very low accuracy. So we had tested it with like 5 or 6 documents, and we saw really good results, like 80 to 95% accuracy. So we're like, it's better than nothing. If our janky algorithm can't do it, we can throw the LLM at it. And so we built it, and we made sure it worked. But when we really tested it at scale, we noticed that it had low accuracy. So eventually we did turn it off. Along the way, though, we actually learned some really important things. So first of all, we learned how to actually deploy an LLM. So by the time the models got more powerful, the tooling around it got more powerful, we are ready to actually plug it in and operationalize it in a production capacity. So that's really cool. We also learned that if we put it out there and we test it against data that's already flowing through the system, we can actually get a very good indication of how well it's going to do once we turn it on. Now, in the case where we first hosted it, we found out that the answer was it's not ready. I think it was getting like 30 to 50% accuracy. Pretty bad. And so we didn't turn it on. But the mechanisms we built along the way to actually test it and judge whether it was doing a good job, we still use those today. And we've actually pointed them at the janky algorithm, and we get pretty good results there. So then we're thinking, part of why this kind of sucks to host this LLM is it takes about 30 to 40 minutes to like change anything. Really slow development turnaround, right? We could run a smaller model locally and get somewhat reasonable results, but it wasn't until you actually ran it in the cloud that you would actually see whether it would really work. And so we were thinking, well, let's just build our own rig so that we can run it here in the office. So we went to work, spec'd this out. I think this is like December of 2023. By the end of December, we actually went to purchase it, and we ran into a problem. GPUs were not available. So I don't think this was because of AI. I actually think there was like a pickup in Bitcoin mining. But for some reason, the GPUs we had spec'd out, we could not find 2 of them. We could only find 1. So we did buy it, but we bought it for about $1,000 more than we wanted to. We did eventually find a second one, but it was used. Then we ran into a problem where we had designed the computer for everything to fit inside of it, but we didn't consider how the GPUs would mount. And so we got them in there, and they were actually like bending their mount points. And we also realized we couldn't put an NVLink in there. There was no room for it. So if you don't know what I'm talking about, an NVLink is like a bridge that you can put 2 GPUs together. They can basically share memory. So large language models require a large amount of memory, so you want to have as much onboard memory available as you can to run them efficiently. And so we realized the case was too small, and so we had to kind of scramble to figure out what to do. I'll show you a picture in a second. I think it turned out pretty good. The other big failure I would say is we did what we needed with this R&D rig at the time. This is January of 2024. For about 2 to 3 months, we were using it at the level that made sense to pay for it. But quickly after that, we kind of pivoted and went on to other feature development, and we've kind of left this thing idle in the background. So it's not used as much as we would like to use it, just because product priorities have gone other ways. Now, some of the successes for this R&D rig, in the grand scheme of things, it was a modest investment. I think it paid for itself in the first 3 months by running it locally. We were able to basically, instead of running it in like the cloud, we were able to basically recoup all the cost. The failures we ran into, so the hardware availability, the case being too small, actually required everybody on the team to pitch in and figure out how to solve the problem together. So it was a really great team building exercise. Wasn't planning on it, but it turned out to be pretty good in hindsight. The other thing is when we set it up, we actually made it so it could connect to the cloud, so that if we wanted to do like a beta feature, we could actually run it on this thing and judge whether it was good before we invested the hardware to get it for real. Definitely not productionized, but it works. So this is Betsy. This is our R&D rig. So in the middle, you can see kind of it in its finished glory. It's sitting in our office in one of our conference rooms. But I mentioned the graphics cards didn't fit. So me being a woodworking enthusiast decided I can probably build a custom case for this. So the right side is actually the case we bought. The left side is a little extension case that I built. And you can see it kind of looks real. I mean, maybe I have a future in building hardware cases. It is wood, so there's a little bit of a fire risk, but I made sure to put in like wire meshing, and so the airflow's good and everything like that. But I'm very proud of this. I think actually Bill's here tonight. His wife printed off that logo for Betsy, so she did a really great job on that too. But yeah, so anyways, we don't use this that much, but it kind of looks cool, and every time I see it, I remember, last January when we were trying to figure out how to make this work. And ultimately, though we didn't use the technology we bought it for, it did what it needed to do for a couple months. We do use it occasionally now for some R&D. So I mentioned how the large language model we hosted was kind of a complete flop, 30 to 50% accuracy. So a little bit more time goes by, the tooling and the community grow up around large language models, and there's this new concept of fine-tuning, where you can use open source technology to actually tune the model. Now, what you're doing, you're not actually building a large language model when you're doing this. The large language model is very expensive to build, millions or billions of dollars to build one. So that's why there's only a few companies that build them. Although I think DeepSeek is like making it like 10% of the cost, if it's even real. But anyways, you can actually go on top of the LLM and actually adjust the weights it uses to decide what the answer is. And you can do that based on your own data. And so we have this production system out there, Briefli's out there, collecting all these documents. We have people that are manually, they're reviewing the data because these are business transactions. They're making sure it's right, and they're sending it to their system of record. So we actually kind of lifted that data off to the side and used it to fine-tune our model. None of it left our office, so we did not exfiltrate any of their actual data. But we were able to do this fine-tuning. We did see a substantial accuracy increase. So where we were seeing 30 to 50%, we started seeing upwards of 87% accuracy, which is great. The problem is we could never actually get over 87% accuracy, and turns out in business transactions, 87% is not good enough. You need somewhere in the high 90s to make this worth people's time. So we were not able to use the fine-tune model, but we got a step closer. We do expect, as the new models come out, to be able to do these kind of fine-tune operations and get that increased accuracy. We just need to start a little higher than 30 to 50%. And finally, our final thing we call it click to configure. So this is actually not AI. It's not even close to AI. It's just user experience. So as we were struggling with the LLM, we decided to kind of pivot and just say, well, if we just blast these documents with every question we've ever asked them, and then we force rank them to the highest accuracy that TextTrack tells us, we can actually show the user all the possible choices and make them think that it's AI. And that's what we actually do. And so we saw some other benefits of this, right? So when a customer is new to the system and you show them all the data that we found for you, they think it's like really cool, and they get to actually pick the stuff that they think they want. And they get that immediate feedback that, hey, I clicked that address and now it's part of my extraction. Hey, I clicked that data point, now it's part of my extraction. I reconfigured the tabular extraction and I can now see a preview of it. It's very quick. It's very easy to understand for our users, and they really like it. So this actually allows us to onboard new customers quickly, helps us make a really cool demo, and it's simple and it's quick. It does have some rough spots, so we're still figuring out the UX. So even though we think we've made it significantly simpler than most of our competitors, there's still some extra dials that you can turn that we haven't really figured out good ways to do that. And so there's still a lot of work to do here, but it's going really well. And lastly, because we are the experts of this user experience, sometimes to help get our customers on board, we actually have to step in and actually configure it for them. So that does take a little bit of cost from customer support. So I drew this all out kind of in a timeline, and I did focus only on our AI-related efforts. But you can kind of see over time, since early 2023, since we were founded, we've kind of had some highlights along the way. But you also see all the lowlights, all the things we tried that didn't work. And some of these actually cost real money, and they never made it into the product. But the cool thing is where we are today, we see a lot of opportunities going forward based on what we've learned. So two major things are kind of what I see, and if I think about it longer, maybe I can think of some more. But this is what I wanted to talk about in the presentation. So what's really cool is as this has grown up in the industry, they've actually, AWS is actually offering a large language model as a service. So think like the best of ChatGPT, Google, whatever it is, you can actually use all those models on AWS infrastructure, and all you have to do is say what model you want to use and provide it the prompt, maybe the image if you have an image, if you're using vision models, and it can return you a response. And so the reason I think this is really powerful for our product, and a lot of people are doing this in other ways, but we can actually use large language models for very targeted scenarios. So we still have a few things that we just can't get very well when we extract data. No matter how much we make it seem easy to the user, there's just some values that are hard to get consistently. And so with large language models as a service, we can actually more quickly iterate on those features and get very quick results. We don't have to take all that time to stand up all the infrastructure. The other thing we started doing was doing team-based R&D. So we have, I think we have 6 topics in our R&D hopper right now, and we've only really attacked one of them. But we've started introducing R&D features, if you will, into our roadmap. So everybody knows when they're coming. Those people that are interested in that R&D can speak up and get assigned to it. And it keeps us honest for like pursuing these R&D efforts in earnest. We did shift them. So in our original R&D, we were very much like, hey, LLMs are really cool. What can we do with them? We didn't have a specific problem. We didn't know what we wanted the results to be. We just started playing with the technology. So all of our new R&D goes the other direction. There's a specific problem that a user or potential user is facing, and we want to solve it with whatever technologies make sense. We do put in a little constraints, like we expect it to be just as fast as our current solution, or more accurate than our current solution, or cheaper. We know those things up front when we start the R&D, and that helps us fail faster. It gives us more structure around the R&D so that we don't just endlessly pursue it. And then lastly, we make sure we document everything really well, because we know that the things we learn along the way are not necessarily going to lead to an immediate success. It may be something that we benefit from 6 weeks, 6 months, 6 years down the road. So we want to make sure we write it all down while we're pursuing it. So So that's really kind of our story about integrating AI into our product, and I just want to kind of close it up with some lessons learned along the way. So that last one I mentioned has been one of our biggest lessons, which is start with a very specific problem if you can, right? If you just try to integrate all these technologies or try to use them, play around with them, you can waste a lot of time never solving any problem. But if you have a very targeted problem to solve, these AI models are actually really good at solving very specific problems. And you may want to even consider a different model for a different problem. So think about, like, you may have 5 problems to solve and 5 different solutions for it. Also, if anybody is working on a team around integrating these technologies, it's really important to keep the team engaged and aware of what's happening so that you don't run into some silo problems. So our early R&D that we did, that early standing up of the LLM, by the time it was done, there was only really 2 people on the team that knew how it worked. That was kind of a problem. We have a 7-person team here in Springfield, and it became really hard to ask anybody else on the team to actually contribute to it because they had no idea what it was. We also saw some problems with the person who focused on this. They kind of got disconnected from the team. They kind of didn't know what the features were that were going through the board. And so it was actually really hard for them to get back in the flow of things when it was all said and done. So if you're going to approach this R&D and you're in a team-based environment, definitely find ways to share it amongst the team, not just focus it on one individual or a couple individuals. Next up, we learned this in our early days, but we actually think of this every time we do any R&D, which is to make sure you have a test harness to validate whatever you think is going to happen. A lot of these large language model technologies, they do really well for very specific instances of a problem, but when you try to scale them up to a general solution, they fall over pretty quickly. And they're not really easy or straightforward to actually articulate with the measurements that you probably want to do. So think about how you're going to test the accuracy of this thing before you actually put it out there live. Because actually, I think in hindsight, that was actually most of our engineering, was knowing whether it was working. And then the last thing, just keep trying, right? You're going to fail. You're going to mess up. You're going to get to roadblocks or dead ends. But you got to keep trying different things because the technology is impressive, right? And like, it's changing every day. So if you stop trying at these things, you're going to get passed up. You're going to miss out on the solution that you could have had to your problem if you were just paying attention. All right. That is all I have. I will take questions. So I don't know if you have an extra mic to, sweet.
Obviously, the idea of kind of going fast and failing forward is a very popular idea. Was there ever a situation in your business where you're like, I think I'm going to fail going this direction, but I'm going to learn so much from it that it's worth doing anyway?
I mean, does every day count? Like, I mean, yes. So like early on, we were trying to figure out how to get this tabular data out. And I was pretty confident at that night in Salt Lake City that I was not going to be able to figure it out. I only had like 6 hours, maybe 8 if you only need a couple hours of sleep. And I was like, there's no way I'm going to pull this off in the next 6 hours. We had done a lot of cool stuff that got me to where I could do it in 6 hours, but I really thought I was not going to make it, but I did it anyways. And so, that night, like that situation has happened at least 20 times in the last 6 months. So yes, we do it. I mean, I have no fear going after big things. I failed enough in my career that I'm okay with failure. So.
What were the specs on the server you guys built? And then have you tried any of the newer models? And did you have any better luck with accuracy with those?
Yeah, so Betsy is, let me see if I can pull it up. So I think the CPU is pretty generic. We did have an extra big like fan for cooling, we thought we could do it with air supply, but the actual GPUs are 4090s tied together with an NVLink. So, Bill, do you know any more of the specs? Yeah, this is one of those things where I was like, you guys all know computers, just tell me what to buy. I trust you. But I do know that they're 4090s, mostly because the first one cost a lot more than I wanted to pay.
I'm going to add on to that real quick. Did you guys consider like an open air case at all? Like, did it need to fit inside of a case?
Yeah, I mean, like, it didn't necessarily, but we don't have a server room in our office, and we needed it to be in the office. So we did consider like an open air setup, but like we needed it to not drive us all crazy. And so that's why we went this route. To answer Ryan's other question, other models we've tried. So if you guys are familiar with, there's a vision model. So it's purely looking at the pixels, not the language. You can prompt it like you do normal models, but instead of interpreting the words, it's actually looking at the pixels on the document. We have done a lot. That was actually our most recent R&D. We chose the Llama Vision model, the 90 billion parameter one. There's some lower parameter ones that you can use, but they weren't very accurate. We actually were able to get very clear accuracy with that. So we actually used it for, so I mentioned we do tabular data and queries really well. There was this one format of document that was very well designed for a human. It's like a checklist, but like it's not designed for it. Our tabular data didn't even find it. So we did use Llama Vision for that and saw, I think it was 99% accuracy. So the new models are very powerful. We don't need that in our production instance right now because we don't have a lot of use cases with our existing customers, but we did spec out how we would integrate it into the platform. And we were about to pull the trigger, but then the potential opportunity fell off the map. So, but now it's like our backup plan for everything we can't do. So we have a really good test harness, and we can really quickly iterate. Within like half a day, we can have it up and running, which is really cool. What else? Anyone?
Sorry, you're going to hear from me a lot tonight. You talked a lot about algorithms in the first part of your presentation here, and then you moved on to LLM. So I was just curious, maybe this is proprietary, but like, what kind of software or technology were you using to make these algorithms? Because I can't imagine you sitting in a hotel room for 6 hours in Salt Lake City, looking at a document, PDF document even, and then trying to read whatever code that is, that binary format. So what are you talking about there?
So this is so our algorithms happen with semi-structured data. We already have semi-structured data that comes from TextTract. So there is a first pass OCR and some semantic like recognition of like the layout of the page, and we can use all of that information to do it. So we're just doing data processing. It's all in JavaScript. Well, now it's TypeScript, but it's like back assword TypeScript. We just kind of retrofitted it with TypeScript, so it's still pretty terrible.
So I told Levi this already, but it occurred to me later in the presentation. You said that you created a UI, and customers are allowed to select the data that they like and that they want. In my mind, I thought, wait a minute, are these guys really building a CAPTCHA?
No, it's even simpler than that, actually. We've ran every permutation of thing we want to grab off the document before the user ever sees it. And then all they tell us is which ones they want. Yeah, but like they're not like causing it to extract data from that part of the document. It's already happened ahead of time. I don't think that's proprietary. Hopefully not.
What's the usual turnaround time when you get a new customer that has their bill of lading stack that they want to fire up? Is it like a week? You said that the target was 6 weeks or something like that they were fighting against?
Yeah, so the EDI integration is 6 to 8 weeks, sometimes longer based on whatever's going on in the business. No, for us, it's about 15 minutes.
Nice.
And it's usually only 15 minutes if they have, like, if they're not familiar with like what they're trying to do. For people that are like, like they understand the UX and they've done it before, it can be, I mean, I test a setup like I probably do about 20 a day, and I can set one up in about 5 seconds. So it's designed to be as fast as the user can go, but usually it takes about 15 minutes. Actually, the thing that takes the longest amount of time is saying where the data goes in their system. So we do give them kind of a relatively easy way to say like, oh, it's the bill of lading on the document, but in our system we use that as the reference number. And so they do have to do some data mapping, and that's part of the 15 minutes. Any other questions?
Going
All right.
once. Going to okay. Go on.
At one point, you mentioned that you had used data from different companies that were using your service to help train one of your tools. I don't remember.
Yeah, to fine tune our LLM. Yeah.
Where do you draw the line, or not the line, but how do you define like ethical use of data, where if they consented to that, the use of that data or not?
Yeah, so the terms of our service are that we have access to the data while they use our tool. And so just to clarify, like we were building a layer on top of the LLM that was remaining proprietary. So none of this data was leaving our network. It was all used for tuning of that model. And then that tuned model, we were hosting ourselves. So none of this, so their data was it was never exfiltrated out of our system. Yeah. So from an ethical perspective, I don't have a lot of opinions about this, but in my mind, if I'm using your data to give you better results, that is a very ethical use of it. I'm not selling it to somebody else. I'm not using it to help out some other customer. It's actually tuning it for your sake. So that's where I think we draw the line.
I'm clearly a very curious person. So you talked a lot about your test harnessing, and a thought that just crossed my mind was that I believe astronomers or some scientists, one of the ways that they test their to make sure that whatever their predictions are going to be for their models are accurate, is they kind of feed it fake data and then see if like it produces like a real result, and then they can actually throw it against real data and get real results, right? Is that how your test model operates, or is it a different way?
Yeah, so we do have fake data that we put inside alongside the other data. We don't do any negative testing, which actually is probably a pretty good idea, where we test like terrible data, like it's never the right answer, and see if it gives us terrible results, because LLMs do have the tendency to not know how to say no. So they'll give you an answer whether there's a real answer there or not. We haven't done anything like that. But now I think I kind of want to. Yeah. So yeah, when we're testing our system, we have a few partners that have given us the ability to actually test with their documents. And so a lot of our test data comes from these sample documents that they've allowed us to have. We do also generate our own samples. The problem is like if you're generating it, you're kind of giving yourself an easy win. So we got to be a little careful about that. We like the diversity of actual documents if we can get them.
Sorry, I missed your presentation, Ben. For some reason, I thought it started at 7, so I was pretty close to being on time. So you tested your software interprets bills of lading, is that right?
Yep.
So for other types of documents?
So the concept actually works for any document.
So I've
We've
got
actually
a whole bunch of PDF scans.
Yeah.
Some have data matrix barcodes in there with some intelligence. Others don't. And they're 300 DPI. You know, can I go through hundreds of thousands of those things and deal with them? I mean, will you sell me that service?
Yeah. Yeah,
Okay.
actually our sales guy is right over here. His name's Mike.
Okay. I was
he would
thinking
love
about-
to talk to you
thinking
about that.
about using like, Amazon's, what is it, the MTurk, service for some of that. But yeah, I'd like to talk to you guys about that.
Perfect.
So,
So our initial target audience is warehousing logistics, and the most common documents we see are bill of ladings, packing lists, or pick tickets. Those look a lot the same, and commercial invoices. So out of the box, we try to classify any document as one of those, but we also let you customize it. So if you have a special format of document, all we say is like the extraction configuration is based on what you would, if you look at the document, you'd say that's the same document as these other thousands. So we let you configure that document type, and we let you customize as many as you want. Sorry, go ahead. I can repeat it.
So we could give you like a text file with all the fields, maybe it's a couple hundred, and you would use that to interpret, or do you need something like that?
So we're designed right now for a human to go in and say, this is the data I want, this is where it goes. But we would love to talk about like different ways to speed that up for you. Yeah, it's not completely automated.
Can you spit out a text file of every single field that's in there for us?
Yes. So currently our integrations are mostly with WMSs, where they have an API that we can talk to. But we also have the ability right now to customize an Excel based on a template. So that's probably the easiest path forward. But we have access to all that data. We're just looking for use cases to decide how to format it on the output. But we've been building up, we approached this problem kind of incrementally, where so our first integration was with the WMS, but then we quickly added a second WMS, and then we added Excel, and then we added SFTP. And so we've kind of created a pattern of, if you tell me what you want to get it out to, whether it's a third-party API or you wanted a special format, within a couple days we can actually have that integration available for you so that you can get it in whatever format you want.
You're not going to take over the world, are you?
I mean, I'd love to, but no, I don't think so. Yeah.
So going back to your model, and don't feel obliged to overshare or anything, but you talk about you get the initial data and then you use it to further train the model, et cetera. And I know you have testing, but how are you avoiding maybe like overfitting that model a little bit by kind of like recycling that same data through it again and again?
Well, first of all, the model is not live. It is not being used. So we don't have that problem. But the way the tuning is set up is it takes, let's say you have 1,000 documents that you wanna do it. It grabs like the first 75% and trains on those, and then it tests with the last 25%. So yeah, you can overfit it, but like what we do is we say, what's the accuracy on the other 25%? Because in all these samples, we know the input and we know the final output because a user has actually verified it. And so there is risk of that. And actually, we've been tuning it on and off for about, like 6 months. I think it trains at like 2 a.m. and it uses new files from production periodically. And we've actually we haven't had a new version for about 6 months. And that's because it doesn't get a better accuracy. It's basically over-tuned it, and the accuracy is lower than the one that came out 6 months ago. And so we track all the different accuracies and the speed and all that, and we only promote it if we get better numbers on both speed and accuracy.
Got it. Okay. Then
So we throw away a lot of tunes.
What percentage accuracy are you seeing? Like what is your happy place? Because 100%, that's bad. But
well, I mean, it's not possible. But no, so in production, we want to be able to have 99% accuracy. So right now the queries, that's the term we use. That semantic extraction, that is currently sitting. It ebbs and flows weekly, but we look at it every week. It's usually between 98 and 99% accurate. The tabular data is where we see a lower dip. It's like 92 to 93% accurate. And so The hope is that we make it really easy for them to make the corrections, but we still do require a user in the loop.
Cool. Thank you.
One more over here. We'll wait for the microphone this time.
So, sorry, again, I missed. What about handwritten data? You just extracting machine printed text, or what about handwritten information?
Yeah, so our a lot of times actually on bill of ladings you'll have a tracking number or a serial number that's handwritten. We do fine. The problem always comes in like the same problem humans have, which is that a 4 or 9? So it doesn't get it perfect every time, but for the most part, yeah, if it's clearly written on the page, and we've had some examples of some pretty terrible handwriting that it still gets pretty well. I don't have a hard number on that. I can tell you though, one of our newer customers, every single one of their documents has handwritten stuff, and we're seeing that 99% accuracy still. So they're not having to make a lot of corrections. But universally, I don't know what the number is.
If a customer were to make a correction, how do you handle that process? Because in my mind, I would have like some sort of backlog saying like, well, first of all, you already know that it's like 99% or something, right? But that 1% could still get through the cracks. So how do you track and then bring that back up with the customer saying, hey, look, this document does need some manual intervention?
Yeah, so we have a monitoring. We monitor the accuracy. So if we see a dip below, I think 85%, we'll actually reach out to the customer. We've done it, I'd say probably 10 times in the last 6 months. We didn't have the monitoring until about 6 months ago. So, and almost every time it's when they were setting it up, they made an assumption in the data that's not even true anymore. So the document format has changed, and they haven't reconfigured it to match that. So. But yeah, so we do know our terms of service is very much like we are here to help you get the data out faster, but like ultimately it's your data. So we don't actually claim to have 100% accuracy. We still say it's their burden. But like what a user experiences compared to having to hand type it, it could be anywhere from 5 to 20 minutes to hand type it. We get it to them in 30 seconds or immediately if they've done it asynchronously, which is what we tell them to do if they can. And so they're making 5-10 second corrections. It's much faster to read through 20 data values and detect an issue. And we show it right next to the document, so it's kind of easy to correlate, than it is to actually type it in yourself, which they still make mistakes when they do it by hand. Because these are like 10-digit numbers, and they have to enter like 30 of them for an order. So, yeah. Why they haven't gone to all barcodes, I still don't understand. Because like that makes sense too. Yeah. So like there's a bunch of interesting things that happen in warehousing and logistics. So, but our tool is meant to kind of smooth off the rough edges. All right.
All right, give Ben a huge round of applause.